In problem 6, we have two vectors, and in part A, we are asked to find the dot product between vector A and vector B. And since we're given the components of each vector, we're going to use the fact that A dotted with B is the x component of A multiplied by the B x component plus the y component product of each vector plus the z component product for each vector. So this gives us 6 times 5 plus 4 times a negative 6 plus a negative 2 times a negative 3. And if we multiply these out, we get 30 minus 24 plus 6, which is 36 minus 24, or 12. And you notice that a dot product gives you what is known as a scalar, so it's not a vector. So sometimes this is referred to as the scalar product because you're multiplying two vectors and you're getting a scalar back. In part B, we're asked to find what B cross multiplication with A is, and this is different than the part A. And to perform a cross product, we start by writing a matrix determinant in the form of I hat, j hat, k hat in the first row, and then this is important. We have to put the first vector, which is in this case B, that appears in the multiplication, and we put the components of B, which are 5, negative 6, and negative 3. And then in the last row, we put the components of A, which are 6, 4, and negative 2. And if you recall from your college algebra, if you've taken determinants, the determinant of a matrix is defined by expanding over a row or a column. It is much easier to use the first row, which gives us a positive I hat, and then we delete the column and the row where the I hat comes from, and we notice that we have minus 6, 4, negative 3, and negative 2. And the determinant of that 2 by 2 matrix is negative 6 times negative 2 minus a 4 times negative 3. And then it's a minus j, so the expansion around the row is going to alternate signs. So the first one is positive, the next one will be negative j times. If we cancel the row and the column where j comes from, we're left with 5 times negative 2 minus 6 times negative 3, and then plus k hat, ignoring the row and column where k hat comes from, we get 5 times 4 minus 6 times negative 6. And if we do these multiplications, we get 12 plus 12 in the I hat direction minus a negative 10 plus 18 in the j hat direction plus a 20 plus 36 in the k hat direction. And combining like terms, we get 24 I hat minus 8 j hat plus 56 k hat. It's important to note here that in terms of the dot product, the order we multiply is not important, meaning A dotted with B is the same as B dotted with A, but in the case of B crossed with A, that's not necessarily equal to A crossed with B. So it is important the order in which you multiply vectors when it's a cross product, but it's not important when you multiply them using the dot product.